Hi, this is part 2 of video. Temperature removal by using a re-entry vehicle design. So part 1 I have already posted earlier. Here I have referred one paper, Preliminary Structural Study and Design of SNC Dreamchaser by Vittorio, Alessandro, del Buono et al. There are 3 authors. So in this, I'm going to talk about re-entry vehicle design. For having a design of re-entry vehicle suitable for debris removal, we should have a cross range as shown on the graph here, figure 1. So figure 1 shows cross range versus L by D hypersonic, lift to drag ratio. It should be between 1 and 2. Cross range should be 1600 kilometers. So we have got a history of space shuttle M2F3, HL10, X24 space planes. So these fall into the category of L by D 1 to 2, and cross range will be 1600 to 1800 kilometers. And there is one more X24B which lies in the range of L by D more than 2.5 to 3, and the cross range will be 3000 miles or 5000 kilometers. So now we will see how to design the re-entry vehicle. So now I am referring the same reference. So this one, reference 1 says, it is talking about HL20, Dreamchaser and all that. So HL20 I am following here. So figure 2, figure 3 and figure 4 will give an idea about the HL20 vehicle. So I am taking HL20. So this is the crew compartment is shown here in figure 2. Okay, this is HL20. So it has got ribs as shown here. It is actually a tubular cross section. So it is nothing but, so in this tube we can always insert my idea as shown in the previous video, that is transpiration cooling. So I will have this one, there will be a passage, that is top layer and bottom layer. In this tubular section I will have, the sheet will be made of annular passage. Top layer will be SS, bottom layer will be SS. In between these two annular passage, so there will be a passage, there will be Teflon will be stuck, 60 mm or 70 mm of Teflon will be stuck. So that is an ablative material. When the temperature is around 1650 degrees centigrade, that is the skin temperature for orbital re-entry. So there then the ablation will start. So that will ablate the Teflon. Teflon will become gas instantaneously. Then it will pass via the annular passage. It will go to the boundary layer, and then there is a transpiration cooling because it is going out of the shell, the outer shell, which has got lanced holes. So that will be passing out of the lanced holes. So in that process it will be cooling the outer shell. So that will be transpiration cooling, and the idea is to keep the outer shell without melting. The melting temperature will be around 1400 degrees centigrade. So the skin temperature will be around 1650 degrees centigrade. So extra 250 degrees centigrade. So that is the load of the vehicle. So that I have to compensate by using ablation cooling, transpiration cooling, and re-radiation, and also convection cooling. So re-radiation will happen on the vehicle outer surface, outer shell. So depends on the heat load. So depending on the kilowatt level, so there will be a skin temperature. So depending on the heat load, there will be this one, there will be re-radiation temperature. It will be set, and after that is, it is crossing the re-radiation heat load. So suppose the vehicle is not able to re-radiate the complete amount of heat load, then what will happen is you have to go for the ablation gases will be going to the powder layer. So then there will be a convection cooling happening in the powder layer. So that will be taking care of the extra 250 degrees centigrade. So this is the idea of the heat shield, that is thermal protective system in my case. So HL20 has got a heat shield. In the figure number 3, it is having pica, that is it is actually phenolic impregnated carbon ablator. So carbon ablator will be used in so many cases. Only instead of phenol, they will be going for some other resin. It's different cases. So instead of all this, this one, the heat shield will be changed. It will be changed to transpiration cooling in my case. So I'll use Teflon. Okay. So figure 3 and figure 4 you can see here. Figure 4 is the plan view of the HL20 vehicle. So HL20 and Dreamchaser will be similar, almost similar. So any re-entry vehicle, you can have the model of HL10 or HL20 or Dreamchaser like that. You can design based on the ideas given by HL20 or Dreamchaser. That's all. But your cooling methodology may be different. It may not be. It's all passive only, but it may not be a pica or some other heat shield, ceramic tiles or something. You can use your own technique. So here I am using a different TPS or cooling technique in my case. Thanks a lot for watching. Thank you.